This chapter provides an introduction to the Java Message Service or the JMS API, a Java API that allows applications to create, send, receive, and read messages using reliable, asynchronous, loosely coupled communication. This topic covers the following subtopics: overview of the JMS API, basic JMS API concepts, the JMS API programming model, creating robust JMS applications using the API in Java EE applications, and further information about JMS. Now, the overview of JMS API defines the concept of messaging, describes the JMS API and when it can be used, and of course explains how the JMS API works within the Java EE platform. First, what is messaging? Messaging is a method of communication between software components or applications. A messaging system is a peer to peer facility in which a messaging client can send messages to and receive messages from any other client. And each client connects to a messaging agent that provides facilities for creating, sending, receiving, and reading messages. Messaging enables distribution communication that is loosely coupled, and a component sends a message to a destination, and the recipient can retrieve the message from the destination. However, the sender and the receiver do not have to be available at the same time in order to communicate. In fact, the sender does not need to know anything about the receiver, nor does the receiver need to know anything about the sender. So the sender and the receiver need to know only which message format and which destination to use. In this respect, messaging differs from tightly coupled technologies such as the remote method invocation or the RMI, which require an application to know a remote application's methods. So messaging also differs from electronic mail or email, which is a method of communication between people or between software applications and people. Messaging is used for communication between software applications or software components. Now, what is the JMS API? The Java Message Service is a Java API that allows applications to create, send, receive, and read messages. Designed by Sun and several partner companies, the JMS API defines a common set of interfaces and associated semantics that allow programs written in the Java programming language to communicate with other messaging implementations. The JMS API minimizes the set of concepts a programmer must learn in order to use messaging products, but provides enough features to support sophisticated messaging applications. It also strives to maximize the portability of JMS applications across the JMS providers in the same messaging domain. The JMS API enables communication that is not only loosely coupled but also asynchronous and reliable. Asynchronous in a sense that the JMS provider can deliver messages to a client as they arrive, as client does not have to request messages in order to receive them. And reliable in the sense that the JMS API can ensure that a message is delivered once and only once. Lower levels of reliability are available for applications that can afford to miss messages or to receive duplicate messages. And the current version of GMS specification is version 1.1. Now, when can you use the GMS API? An enterprise application provider is likely to choose a messaging API over a tightly coupled API, such as the remote procedure call or the RPC, under the following circumstances. The first one, the provider wants the components not to depend on information about other components' interfaces. Um, so these components can be easily replaced. Other circumstance is the provider wants the application to run whether or not all components are up and running simultaneously. And the application business model allows a component to send information to another and to continue to operate without receiving an immediate response. For example, components of an enterprise application for an automobile manufacturer can use the JMS API in situations like this. The inventory component can send a message to the factory component when the inventory level of a product goes below a certain level so the factory can make more cars. The factory component can send a message to the parts components so the factory can assemble the parts it needs. And the parts components in turn can send messages to their own inventory and order components to update their inventories and to order new parts from suppliers. And both factory and parts components can send messages to the accounting component to update budget numbers. And the business can publish updated catalog items to its sales force. So using messaging for these tasks allows the various components to interact with one another efficiently without trying or tying up network or other resources. Okay? And manufacturing is only one example of how an enterprise can use the JMS API, and retail applications, financial services applications, health services applications, and many others can make use of messaging. Now, how does the JMS API work with the Java EE platform? When the JMS API was introduced in 1998, its most important purpose was to allow Java applications to access existing messaging oriented middleware, such as the MQ series from IBM. And since that time, many vendors have adopted and implemented the JMS API, so a JMS product can now provide a complete messaging capability for an enterprise. Now, beginning with 1.3 release of the Java EE platform, the Java Messaging Service API has been an integral part of the platform, and application developers have been able to use messaging with Java EE components. Now, the JMS API in the Java EE platform has the following features. The application clients, the AGB components, and web components can send or synchronously receive a GMS message. An application clients can, in addition, receive GMS message synchronously. Applets, however, are not required to support the JMS API. And message-driven beans, which are kind of enterprise bean, enable the synchronous or the asynchronous, I mean, consumption of message. That is, a JMS provider can optionally implement concurrent processing of messages by message-driven beans. And message send and receive operations can participate in distributed transactions, which allows JMS operations and database accesses to take place within a single transaction. The JMS API enhances the Java EE platform by simplifying enterprise development, allowing loosely coupled, reliable, asynchronous interactions and among Java EE components and legacy systems that is capable of messaging. Now, a developer can easily add new behavior to a Java EE application that has existing business events by adding a new message driven bean to operate on specific business events. The Java EE platform, moreover, enhances the JMS API to provide support for distributed transactions and allowing for the concurrent consumption of messages. Now, the JMS provider can be integrated with the application server using the Java EE connector architecture, and you access the JMS provider through a resource adapter. And this capability allows vendors to create JMS providers that can be plugged in to multiple application servers, and it allows application servers to support multiple JMS providers. Now that is how the message consumption is being described in the JMS API. So the next section will discuss the JMS API programming model.